Hello and welcome back to yet another video in this Hadoop Made Easy series of videos. So this is the fourth video in the series where I'm going to discuss about a few more problems in MapReduce. So the previous video, the video number 3, was all about getting started, an introduction to MapReduce. But just one problem is not at all sufficient to have a fair understanding of how MapReduce works, or it won't help you to think in terms of uh, writing code the way MapReduce works. So a couple more examples which will be discussed in this video and in the next video should actually give you a fair idea about how to think in terms of solving a problem using MapReduce. So the prerequisites for this video is the video number 1, 2 and 3 in case if you are new to MapReduce and Hadoop. Let's get started. The problem statement this time is like we have an input file. The name of the file is newtimes.txt. It's a text file. And the file contents there are just 3 lines in it. The content of the file is highlighted in orange color over here. Pretty much 3 different lines in the file. And let's assume for the sake of discussion that each line of the file is 64 MB. No way it's going to be even 1 MB, just for the sake of discussion, because Hadoop is going to split the input file into 64 MB chunks in case if the file is greater than of size 64 MB. For that reason, I'm asking you to assume that each line of this file is going to be 64 MB. The file has 3 different lines. Now the problem statement is the final output file should contain, the final output of running the program using MapReduce should actually contain the length of the longest words and all those words. Basically, if you see this input, which is basically, this is a sample file, has nothing useful, yet we are using it for example, so we shall use it now. These are the 3 lines present in the input file from which we have to pick out those words which is of the longest length and display them along with that length. So the final output is going to be like 7, example, nothing. So the words example and nothing are the longest words from this input file, and the length actually is 7. So this is what our MapReduce program is supposed to do, or this is what we are going to solve using MapReduce. The only assumption we actually have to make here is that each line of the file is 64 MB. So let's see what happens. Now anyway, each line of the file is 64 MB, so definitely it's going to be split into 3 different input splits, and each input split is just having one line which is going to be processed by the record reader. I'm not going to explain what exactly a record reader is in detail because all that explanation has been covered in the previous videos. So here you pretty much know that the record reader is going to give you a key and a value pair after processing each line of the input file or of each line of the input split. And the key is going to be pretty much the file offset and the value is going to be the entire line. So this output of the record reader is now going to go as an input to the mapper, and we have to program the mapper. And programming the mapper, as I told you in the previous video, is very much related to the problem statement. So it would take a few more examples to get you started thinking in terms of MapReduce. So just try to understand what is happening here in the mapper for time being. So the logic what goes into the programming of mapper, the algorithmic steps are as follows. The step 1 is I'm going to ignore the key which is going to be given by the record reader. In step 2, I am simply going to compute the length of each word in the value. The value is going to be the entire line of the file. Entire line is now going to have several words. So I'm going to compute the length of each word in the line and output the length as a key and the corresponding word as a value. So when you process the line, which is in green color, this is a sample file which has nothing useful. When you try to process that line, now the word this actually has a length 4. The length of that word actually now becomes a key because the mapper is now supposed to emit the answers, emit the results only in key value pairs. So the length of the word is a key and the value is the entire word. So the length of is going to be 2 and the word is going to be is. The length of letter A, okay, I've just missed out A over here, so I'm sorry for that. I've just missed out the letter A. But next is sample. The length of the word sample is 6, and then you have the word itself. So when you process the complete input line, the mapper is pretty much going to output key and values, whereas the key is going to be the length of the word and the value is going to be the entire word. This is the programming logic what goes into programming the mapper. Now let's see what happens next. Now the intermediate output files from all the mapper phases. Now we know that our input file actually is uh, 64 is having 3 input splits, because each line of the input file was basically 64 MB. But what would happen if the original file is very large? What if it was 640 MB? It would be divided into 10 different splits, or 10 different input splits of 64 MB each, and each of those input splits would now be considered as a single independent file. Now, so in this problem, since our input line is just containing 3 lines and each line is 64 MB in size, so we would have 3 input splits. So each of these input splits would be residing on a separate data node, and a mapper program would be running, or an instance of the mapper code would be running on these data nodes. So all of this mapper code, which is running independently on these data nodes having the input split, would produce an intermediate output file, right? The key and the value pair based on what the mapper is programmed to do. Now all these intermediate files will now have to be sent to that one particular data node which is going to execute the reducer operation. So before it actually runs the reducer code, all the intermediate files will have to be grouped together. When I'm speaking about the intermediate files being grouped together, I'm pretty much referring to the intermediate files which is generated as an output of the mapper programs. So all these files will be transferred over the network, and they'll be reaching a destination machine where it's going to undergo a reduce operation. But just before it undergoes a reduce operation, all those intermediate files will be merged to a single file, and then a sort operation will be done on them, and then a shuffle operation will be done on them, and then finally the reducer code will be executed on that one single file to produce a final output. So in this example, say we have 100 nodes in our cluster, and data node 1, data node 2, and data node 3 are pretty much which is having the input splits, and the mapper code is running on these data nodes. So the result of executing the input split 1 on data node 1, the mapper code produces this output, which is where I'm pointing right now, the red box in the extreme left. This is one intermediate file which is the output of running a mapper code on the input split 1. Now the red box in the center or in the middle, is that intermediate file which is a result of operation of running a mapper code on input split 2. Now the third box in the right hand side, the extreme right, is actually the intermediate file generated by running the mapper code on input split 3. Now all these 3 intermediate files are now residing on the same data node where the mapper code was executed. Now all these 3 intermediate files will now have to be sent over the network to one particular data node where the reducer code will be executed. The decision of where to run the reducer code will be taken by the job tracker. So we don't have to worry about, the programmer doesn't have to worry about where to execute the reducer. So the job tracker will take care of it. Now once all these files go to that particular data node where reduce operation has to be done, they'll be first merged together. Once they are merged together, then pretty much shuffle and sort, basically first sort happens and then shuffle happens. So once you actually shuffle and sort them, what would happen is when you try to sort them, sorting happens based on the ordering of keys and not on the values. And then once shuffling actually happens, aggregation of duplicate key values takes place. Basically duplicate keys are removed, and then the corresponding values of the duplicate keys will be chained together, will be attached together in a single list. So if you observe carefully, this is 2 over here, and 2 is repeated over here, and 2 is repeated over here. So, and 2 is repeated over here, and 2 is repeated over here. And I'm just not showing you in a single slide where all these 3 intermediate files are combined. I'm not showing you that, which you have to imagine, or which you're supposed to understand now what's happening when you combine all these 3 files into a single file and run the sort and run the shuffle operation on that. This is what happens pretty much. What you see in the bottom over here in green and blue is what is the key value pair file which is generated as a result of combining all these 3 files and then running the sort operation over it. Sorting happens based on the keys, and then shuffle them, and finally you actually get this file. Now this file, what is sitting down here, the key value pair in green and blue, is pretty much the input to the reducer. Now what was the original problem statement? The original problem statement was picking up those words of the largest length in the entire file. Now what do the keys actually depict? The keys depict here in the final file here. as a result of sort and shuffle, the keys pretty much here depict the length of words. When I say key actually means 2, it means the length of all these words listed in the set of values over here. All these words have a length of value 2. Similarly, when I say key is 3, the list of values over here has all those words. There's a collection of all those words whose length is 3. So looking at this file, which is going to be finally input to the reducer, you must have already decided what exactly you're going to program into the reducer. Yes, simple. You just have to program the reducer so that it picks up the key with the largest item. It actually picks up the largest key among all this 2, 3, 4, 5, 6, and 7. 7 is obviously going to be the largest key. So the reducer has to now be programmed to pick up the largest key and also display the corresponding values, which is nothing but the two words which are nothing and example. So when you try to display the two words nothing and example along with its own key, that's what we are pretty much expecting as a final output. We need to display all those words in the file which is having the largest length. So that's what we have done in the reducer here. So according to the problem statement, the step 1, we actually select the largest key along with the values. So among all the keys 2, 3, 4, 5, 6, 7, this one, the above input, this above file is going to be now the input to the reducer stage or input to the reducer code. Whereas where did we get this output from? Where did we get this key value pairs from? This was the result of sort and shuffle phases. So in step 1, we select the largest key along with the values. So obviously we have to select 7 along with the values. And in step 2, we have to output the largest key and its value to the final output file. So when we try to write the final key and its associated value in an output file, that's pretty much it. So we have solved the problem using MapReduce. So we have identified all those words which has the largest length in the entire input file. So this example must get you one step closer for a better understanding of what exactly is MapReduce. So that's it for now, and hope you had a good time. Goodbye.